once again welcome to another video from iCampSA. In today's video we're gonna be doing a past paper, and this one is from November 2024. These are the common exam. This one is for KZN, I would like to believe, and the area of focus is trigonometry and trigonometric functions and trigonometric functions. Without wasting any more time, let's get to it. Okay, the first question is question 4, and it reads as follow: if 4 tan theta is equal to minus 3 and cos theta is greater than 0, without using a calculator, determine the value of sine theta. Okay, so with these questions, the best thing is to start by trying to visualize what are we actually working with, and try to determine where is the terminal arm located. So for 4.1, we are looking for sine theta, and we are given 4 tan theta is equal to minus 3. Okay, let's rearrange this and make tan theta the subject. So tan theta will be equal to negative 3 over 4. So for this angle theta, the ratio of tan is negative. So we have to determine in which quadrant is tan theta negative. Let's come here to our diagram. We'll draw a sketch that will help us visualize what is happening. And remember our cast method, CAST. We know that in first quadrant all the trigonometric ratios are positive. Okay, and then in which quadrant is tan theta negative? In the second quadrant and the third quadrant, in the fourth quadrant, because in the second quadrant only sine theta is positive, and then in the fourth quadrant only cos is positive. So but we're also given another condition for this terminal arm, and it's that for this terminal arm cos theta is greater than 0, is positive. In which quadrant is cos theta positive? In first quadrant, because all of the trigonometric ratios are positive for the angles in first quadrant. And in which quadrant? In fourth quadrant. So we have 2 stars in what? In the fourth quadrant. That means our terminal arm will be located in the fourth quadrant. What does that tells us now? It tells us that that negative actually belongs to what? Belongs to 4. It belongs to that 4, to the y value, because it is the y values that are negative in fourth quadrant. So we have what? We have here it's negative 4, and then here we have a positive 3, and then our angle, remember, it moves from positive, it goes from positive x values to what? It goes from positive x values to the terminal arm, So it's like that. That is our angle theta. Okay, so, and we know that negative 4 belongs to what? It belongs to the opposite side. Or to the y side. And then that positive 3, it is the adjacent side. Okay, sorry, no, not the negative, not the 3, the negative 4, of which is the y side. Let's see. No, actually here it's gonna be, this is gonna be 4. Yeah, I made a slight mistake there, and this is gonna be negative 3. Yeah, that is the proper way, because 3 is our opposite side, and then 4 is the adjacent side. So I made a slight mistake there. So we're gonna have negative 3 over 4. Yeah, it's just like that. That's the proper way. Okay, and then what do we have to calculate here? We have to calculate the terminal arm. You have to calculate the hypotenuse side, the length of the terminal arm, and we use what? We use the Pythagoras theorem. So we're gonna say, we're just gonna call it r squared is equal to x squared plus y squared. Therefore, r squared is equal to, what is x squared? Is 4 squared plus minus 3 squared. Therefore, r squared is equal to 16 plus 9. 16 plus 9, of which would be 25. We introduce a square root on both sides. Therefore, r, the terminal arm, is gonna be what? Is gonna be 16 plus 9 is 25. Square root of 25 is 5. And that is your answer. Once you have this, you can now actually evaluate. You can now actually evaluate sine theta. So for 4.1, sine theta is gonna be equal to what is the opposite side? Opposite side is -3. So sine theta is gonna be -3 over hypotenuse side. So we're gonna have a -3 over 5, of which makes sense because the terminal arm is in which quadrant? Is in quadrant 4. The terminal arm is in quadrant 4, and in quadrant 4 only cos theta is what? Only cos theta is positive. So it makes sense for us to have a -3 over 5. Okay, and then for 4.2, we have to evaluate 10 cos squared theta. 10 cos squared theta. What is cos squared? What is cos? The ratio of cos is adjacent side over the opposite over the hypotenuse side. So we're gonna have 10 into adjacent side. What's the adjacent side? Is actually 4, and it's positive. So we're gonna have 4 over the hypotenuse side, of which is 5 squared. 5 squared. Yes. So then we're gonna have 10 into what is 4 squared is 16 over 25. 16 over 25. You multiply this. We're gonna have 160 over 25. 160 over 25, of which is 32 over 5, of which is 32 over 5. Okay, and then next we have 3 cot theta plus 5 sin theta. That is our 4.3. We have to evaluate 3 cot theta plus 5 sin theta plus 5 sin theta. 5 sin theta, and we have cot theta. Cot theta is a reciprocal of what? Is a reciprocal of tan theta. So this is essentially 1 over tan theta. 1 over tan theta plus 5 sin theta. What is sin theta? Sin theta is opposite over the hypotenuse. We've already calculated sin theta is -3 over 5. So it's 5 into -3 -3 over 5. Sine into 5 into -3 over 5. And we were given tan theta at the beginning. Tan theta is what? It's -3 over 4. It's -3 over 4. So here we're going to have 1 divided by -3 over 4. 1 divided by -3 over 4, which is essentially -4 over 3. Plus, what is 5 multiplied by -3 over 5 is gonna be -3. This is gonna be -3. Equal sign. And here we're gonna have what? We're gonna have 3 into -4 over 5 over 3. Because 1 divided by 3 over 4 is gonna be 4 over 3. So we're gonna have this minus 3, and then -3 times -4 over 3 is gonna be what? -4. Therefore we're gonna have -4 minus 3, of which will be equal to -7. And there you have it. It's -7. 3 cot theta plus 5 sine theta, and this marks the end of question 4. Okay, the next we have question 5. In each of the following equations, solve for x where x, the angle x, is between 0 and 90 degrees. Give your answer correct to 2 decimal places, So we are told that the angle x is between 0 and 90 degrees, which means the angle x is in the first quadrant, That is what we know. So for 5.1.1, we have to solve for x. So cos x is equal to 2 over 3, and then we simply have to take cos x to the other side. So we're gonna say x is equal to cos inverse. You say shift and you press cos, it should give you this cos inverse. Therefore x is equal to, what is the answer? Cos inverse of 2 over 3. The x is equal to 48 point, give your answers to 2 decimal places, 48.19 degrees. Since we are looking for the angle, and 48.19 degrees is in what? It's between 0 and 90 degrees, so this answer makes sense. Let's go to 5.1.2. 5.1.2. We are given 4 over cot x. 4 over cot x plus 1 is equal to 3. So 1 is equal to 3. We have to solve for x. We are dealing with a reciprocal here. So first thing first, let's take the 1 to the other side. We're gonna have 4 over cot x is equal to 3 minus 1, of which will be 2. And then let's cross multiply. We'll have 4 is equal to 2 cot x. Let's divide by 2 on both sides. Therefore cot x will be equal to 4 divided by 2 is equal to 2. And then once we are here, let's change cot x to actually tan x, something that we can work with. This is equal to 1 over tan x. 1 over tan x is equal to 2. We cross multiply again. We're gonna have 2 tan x is equal to 1. You divide by 2 on both sides. Therefore tan x is equal to 1 over 2. Tan x is equal to 1 over 2. Then to solve for x, we need to take tan to the other side. Therefore x is equal to tan inverse of 1 over 2. Therefore x is equal to, punch this in your calculator, tan inverse of 1 over 2 gives us 26.57 degrees, of which is between 0 and 90 degrees. So it makes total sense. Okay, and then next for 5.2, we are asked to simplify fully without the use of a calculator. So once they tell you not to use a calculator, you must know that you are dealing with what? You are dealing with special angles. And that is 5.2. 5.2. So but first thing first, let me add this page here. Drop just what we are looking for. This is our 5.2. Yeah, so simplify fully without the use of a calculator, and we are given tan 45 degrees multiplied by cosec 60 degrees over cot 30 degrees multiplied by cos squared 45 degrees. So we are dealing with special angles. Hopefully you have at this point memorized the special angles, but if you haven't, we quickly draw the triangles for the special angles. The first one, special triangle, it's a right angle triangle with the degrees 45 degrees, and then 1 unit. We solve for the other side, which will give us now the roots of 2, and then the other triangle. The easiest way, you draw a triangle like this, and then you cut here a line perpendicular to this side. So this is an equilateral triangle, which means all sides are equal and the angles are 60 degrees, and then the other angle will also be 60 degrees, but we split it to 30 degrees and 30 degrees. And for this triangle, all sides are equal to 2 units. So we're gonna have here, these sides will be equal 1 unit and 1 unit, 2 units here and 2 units there. So we just have to calculate the other third side. So the other third side, using the Pythagoras theorem, we're gonna have what? Let's quickly calculate this other third side, which is, let's say it's AB side. AB, we say AB squared is equal to the hypotenuse side, which is 2 squared, minus the other side, which is 1 squared. We're gonna have 4 minus 1 is 3. Therefore AB is equal to root 3, and that those two triangles will give you the special angles. You don't have to draw them in the exams, of course, but if you have forgotten, just quickly draw the sketches. You see, it didn't even take me 3 minutes to draw this, and then we can solve for we can simplify this expression that we have here, tan 45. So we are focusing in the triangle, first triangle A, triangle number 1. What is tan? Tan of 45 is opposite over the adjacent. So tan 45 is gonna be opposite over adjacent. What's the opposite side? Is 1 over 1. So you're just gonna have 1. Tan 45 is 1, multiply cosec. Cosec 60. What is cosec? Cosec, first thing first, is a reciprocal of what? Of sine theta, of sine 60 in this case. So you're gonna have 1 over sine 60 degrees, first thing first, close bracket, over cot 30. Cot 30 is the reciprocal of tan, so we're gonna have 1 over tan 30 degrees, 1 over tan 30, multiplied by cos squared 45. So cos 45 is what? Is adjacent over hypotenuse. So here we have the adjacent side, which is 1 over the hypotenuse side, of which is root 2. So we're going to have 1 over root 2, 1 over root 2 squared. Okay, therefore this is going to be equal to, we have the 1 there, 1 multiplied by 1 over sine 60 is 1 over sine 60. So we're going to have, what is sine 60? Sine 60, opposite over adjacent. So this is the angle we're looking at. The opposite side is root 3 over hypotenuse, since it's the sine. So it's root 3 over 2. So we're going to have 1 over root 3 divided by 2. All of this over 1 over tan 30. What is tan 30? Tan is opposite over adjacent. The opposite here is 1 over the adjacent, which is root 3. So we're gonna have 1 over, this is gonna be 1 over root 3. This is basically just root 3, but let's do it like that first. This one here is this one, and then the 1 over root 3 is for tan 30. Hopefully you are able to make that distinction. Okay, times 1 over root 2 squared is just gonna be 1 over 2. Okay, and then 1 over root 3 over 2 is the same as 2 over root 3. It's the same as 2 over root 3. divided by 1 over 1 over root 3 is the same as root 3 is root 3 multiplied by what? Multiplied by 1 over 2. 1 over 2. Okay, more space. Let me add a page. Okay, this is therefore equal to what now? We have 2 over root 3, 2 over root 3, that's the numerator, divided, let's use the division sign, divided by root 3 over 2, root 3 over 2, root 3 over 2. Okay, and then once we are here, 2 over root 3 divided by root 3 over 2 is the same as 2 over root 3 multiplied by 2 over root 3. Remember, when we change the division sign to a multiplication sign, you have to take the numerator and make it the denominator. So here we're going to have 2 times 2 is 4 over root 3 multiplied by root 3. It's just going to be 3, and that will be your final answer. There. Okay, and that is how you go about solving for that, and it's 5 marks, 5.2. Okay, then next, 5.3. If x is equal to 56.3 degrees and y is equal to 97.5 degrees, evaluate the following correct to 2 decimal places. Okay, I've already copied that, so I would like to believe. Let's come here and paste, and then we drop. We are in 5.3 now. 5.3. Let's drop again. Yes, so we are in 5.3. So if x is that and y is that, evaluate the following correct to 2 decimal places. Once they tell you correct the answer to 2 decimal places, always know that you are you're gonna have to use a calculator to perform that calculation. So we have cos of x plus y. Cos of x plus y, this is equal to cos, we insert x, the value of x is 56.3 degrees plus y is 97.5 degrees. Therefore, cos of x plus y is going to be cos 56.3 plus 97.5. It gives us negative to 2 decimal places, negative 0.90. So this is going to be negative 0.90, and that is your answer. Okay, and then next for 5.3.2 is 2 sine squared x minus 2 over cos y. 2 sine squared x, this is gonna be 2 sine of what is x, 56.3 degrees. 2 sine square of 56.3 degrees, 66.3 degrees minus 2 over cos y. What is y? Y is 97.5 degrees. 97.5 degrees. And remember that sine squared theta or sine squared x, you can essentially write it as follow. This is 2 into sine 56.3 degrees, close bracket, squared. This is how you're gonna punch it in your calculator. Minus 2 over cos 97.5 degrees. And when it's like this, you can simply punch it in your calculator and get your answer. Okay, it's 2 into cos 56.3 squared close bracket minus 2 over cos 97.5, and here we get 10.61. That is your answer, 10.61 to 2 decimal places. Okay, and that is that for 5.3.2. Let's go ahead and do question 6. For question 6, we are doing trigonometric functions, and it reads as follows: the graphs of f at x is equal to p sine x and g at x is equal to cos x plus q for x is the element of 0 to 360 degrees as sketched below. So we're given the graph of sine, of which from the shape we can see that is this graph, and it hasn't been reflected because it starts from 0 and go into the positive direction. And then we have the cosine graph, this one. It also has not been reflected, but it has been shifted. It has been shifted, hence why we have that value of q there. Okay, so for 6.1 we're asked to determine the value of p, and q, so for p, of which gives us the amplitude and the vertical stretch of the graph, we can see that normally we know that the graph of sine goes between 1 and -1. But now what do we see? We see the graph of sine going to 2 and -2. So this sine function has been stretched by a factor of 2. Our amplitude will be there at 2. So the value of p is 2. So we say p is equal to 2. And then for q, the shift of the cosine function, we know that normally the cosine function goes something like this, from 1 like this. It goes like this from 1 to 0, and now we see that it goes from 2 to 1 to 0, and it has been shifted. What is the baseline now? The baseline for this function is 1. So from the sketch we can see that q is 1. Let's say you forget how to read or from the graph itself, you can remember that you can calculate the value of q by using this formula, which is q is equal to 1 over 2 is equal open bracket maximum value, take the maximum value plus minimum value. Okay, then let's go back to our graph. 1 over 2, what is the maximum value? The maximum value is 2. The minimum value here is what? Is 0. So we say maximum value 2 plus minimum value, which is 0. 1 over 2 into 2 plus 0, this will give us 1. So that's another method you could have used to calculate the value of q. Either way is correct. If you are able to read it from the graph, it's just 1 mark. You should do that. If not, you can use the formula. Okay, and then for g at x, the cosine function, you are asked to write down the amplitude of g. So the amplitude, we see it by the coefficient of cos there, of which is 1. So the amplitude for the function of g for 6.2 is just gonna be 1. We say amplitude. So amplitude, it tells us how far is the graph stretched from the baseline, and it's only stretched 1 units if this is our baseline there at 1, and then when we go up from 1 to 2, the maximum value is what is the maximum value is 2, so we only go up 1 unit. So the amplitude of g is equal to 1. Okay, and then for 6.3, write down the range of f, the sine function. So the sine function has the maximum value of 2 and the minimum value of -2. So it ranges between -2 and 3. So we say the range y is the element from -2 to +2 square bracket, because those values are also included. That is the range of f. Okay, and then next, for which values of x will f at x, the sine function, be greater than 0? So we come here, we look for all the values whereby our sine function is above the 0 line, and it's from 0 to 180 degrees, because once we get here it goes below 0. So it's only that highlighted part from 0 to 180 degrees. But at 0, the f at x function is equal to 0, and at 180 it is also equal to 0. So we don't include those. So to present our sine, so to present our answer, we're gonna see 6.2 where x is greater than 0 but x is less than 180 degrees, and that will be your answer, where x is greater than 0 but less than 180 degrees, and that is your answer, greater than 0 degrees, less than 180 degrees. Okay, and then for 6.5, the graph of g at x. What is the graph of g for 6.5? First thing first, let's come here. We already calculated q and it's 1. So 6.5, the graph of g at x is equal to cos x plus 1. That's the original graph of g. What have they done to it now? It's reflected about the x-axis and then shifted 2 units and then shifted 2 units upwards to obtain the new graph of h. Write down the equation for the graph of h. So let's come here. What do we have to do? We have to reflect the graph of g. So the graph of h at x is equal to negative g at x plus 2, and then shifted 2 units upwards. Okay, and then we come here, we're gonna have what? Negative. What is the graph of g is cos x plus 1, so it's gonna have negative cos x plus 1, cos x plus 1. Okay, and then we add that 2, so we're gonna have a negative cos x minus 1 plus 2. Therefore the new equation for h at x will be negative cos x, what is 1 minus 2, negative cos x minus 1 plus 2 is gonna be plus 1. That's the new equation for the graph of h, and that is how you go about answering those questions regarding the trigonometric functions. Okay, so that is that for today's lesson, and I hope you guys learned something from this video. And if you are watching this video from YouTube, please subscribe, like, and share this video with friends, family, and colleagues. And until we meet again, I wish you all good luck and good studying.